Uh, in Kruskal-Wallis test, we used to call compare more than two independent non-parametric samples. For that purpose also, I'm going to use a data set 2.3, the same data set I'm going to use, but in that data set, instead of type of clinic, I'm going to use the labels. So example I have taken that when we want to compare waiting time between three different units of the hospital based upon the specialty or the facility given. One is your primary care, one is your primary care, second one is your specialist, and third one is your tertiary center. That out of these three, primary, specialist, and tertiary center, either the waiting time is more in primary or specialist, or the tertiary center in which the waiting time is more or less. This we are going to find out, and for that purpose we are going to use the Kruskal-Wallis test, which is the one way ANOVA for the uh, not normally distributed data, clear, and equivalent for the non-parametric sample. When I have written here non-parametric sample, it means the distribution was found not normal, and we have not found the bell-shaped curve, or either the skewness was not under the range, or the kurtosis was not under the range. If I am saying range, it means whenever you are going to apply the test for the normality distribution, you are going to get the results of that test in the form of 5 different way. The first one, to see the value of Kolmogorov and Shipravil. The value of Kolmogorov and Shipravil should be more than 0.05. You are going to see the QQ plot. QQ plot should be straight, and if data points are closer to a diagonal line, you can say data is normally distributed. And if you are getting a bell-shaped curve of your data, then also you can say that data is not normally distributed. And two more methods are there, which I think I have not discussed in the previous classes. That means the ranges of skewness and kurtosis. If the skewness given by a software, or the data or the ranges of kurtosis given by the software, if it is under the ranges, you can say that data is normally distributed. And if it is less than or more than the ranges of skewness and kurtosis, you can say data is not normally distributed. And what are the range? Just be remember, for skewness the ranges is -1 to +1, and for kurtosis the range is -1.96 to +1.96. So if your data is showing skewness or kurtosis under or more than this ranges, you can say your data is not normally distributed, and you are eligible to apply the Kruskal-Wallis test. So the steps are similar like the Mann-Whitney test, which we have done today itself only. But instead of choosing Mann-Whitney in the field tab or in the setting, you have to choose the option called Kruskal-Wallis test. So how to do it? These are the steps for the Kruskal-Wallis, and you can see, click on analyze, then non-parametric, then independent sample is the command. Go to field tab. Under the field tab, move the waiting time into test field, and under the groups, instead of clinic, add labels, because label we are going to use for the Kruskal-Wallis. And just you have to change the step number 9. So instead of choosing Mann-Whitney choose here Kruskal-Wallis. Remaining all the steps are same. The two different things you have to do: instead of clinic, choose your labels, and instead of Kruskal-Wallis, instead of Mann-Whitney choose the option called Kruskal-Wallis test. So how to do it? Like this, data you have to fill in the SPSS sheet. ID, not that much necessary. This is the type of clinic which we have used for the Mann-Whitney test, where we have only two different kind of categories. One category was medical and surgical. So for Mann-Whitney test already we have used this one, so I will not use. I'm going to take only these two. One is your label, and second one is the time. So time, which is a dependent variable, should be written in the form of minutes, in the form of numbers, and labels, where we have a three different categories. One is your primary, second is your specialist, and third one is the tertiary. So what we are trying to find out, we are trying to find out that out of these three different settings of the hospital, the waiting time is more or less in which group and in which ward or in which unit of the hospital, and we are trying to compare the median time between these three. So each row is representing to a individual sample or the patient, like this. For example, patient number 1 is visited to specialist ward and waiting time was found 24, and patient number 2 visited to specialist ward and having a waiting time of 15 minutes. So here also, for example, you can run a model where you can use the data of both these clinics as well as label. For example, under the medical, we have a three different units based upon the facilities available in the hospital, and under the surgical, again we have a three different setting in the hospital based upon the specialist. So the model can be designed in such a way that you can use the clinic as well as the label. But if you want to get results of only medical and surgical, then you have to apply Mann-Whitney U. And if you want to apply, want to find the difference between these three, then you have to apply the Kruskal-Wallis. So like this model you have to made for your project, that this can be the one of the objective of your research, that we want to find out that what was the waiting time of the hospital. So hospital is divided, for example, in the hospital, if they have a two section, you can divide that medical section and the surgical section, and under the medical, based on the super specialty, you have a three different subcategories. So this can be chosen as a subcategory. So for both purpose you can apply these two tests. So how to do it? The example is the same. Click on analyze, click on non-parametric test. If you click on non-parametric test, you are going to get a window for the independent samples. If you click on a one independent sample, you are going to get a this non-parametric two or more independent sample window. There you have to click on the field, and in the field you have to choose waiting time again in the test field. And see here, I'm using labels instead of type of clinic, because in type of clinic we have a two units, and under the label we have a three categories. So label I'm going to add in a option called groups here. So whenever you will move the variable into test field and the groups, you have to click on the setting. So when you have finished the work under the option called field, you can move to the second option called setting, and under the setting you have to click on choose test, and under the choose test, this option will appear, and you have to click on customize the test, because here you are going to choose that which test you want to apply. In the previous test we have clicked on the Mann-Whitney U, so this time we will click on the Kruskal-Wallis, because we have a categories more than two. So I will click on the Kruskal-Wallis for one-way ANOVA non-parametric sample. We are going to compare the mean, and I will click on run. So whenever you click on the run, the results will be presented in front of you. Now result says was here. See, in the previous test we got the p-value 0.30, and here we are getting more significant results. That means there is a difference in the median waiting time of all the three uh, units of the hospital based upon the specialty or the facility given. So uh, results table suggest what? The first table will be the hypothesis test summary, and here it is going to tell you that which variable you have used for the study. That means waiting time we have compared with the option called label, and under the label we are having the three category: primary, tertiary, and the specialist, like that. So we have applied name of the test, that independent sample Kruskal-Wallis test, and we are getting a p-value. P-value here we got 0.003. So that means we are able to reject the null hypothesis. So what was the significance level of the test? Significance level of the test was 0.05, because confidence interval while calculating the sample size we have taken 95%. So against the 95% confidence interval we have got this significance level. So this will be taken as a cutoff point, and our p value or the significant value should be less than this. So here we are getting 0.05, and here we got the p value 0.003, which is very less than 0.05. So we can say that our test is passed, and we are able to reject the null hypothesis. Null hypothesis was suggesting that there is no difference in the median waiting time of all the 3 units of the hospital. Clear? So if you want to get the descriptive statistics, like previous test I told you that you have to run another command called descriptive analyze, then click on descriptive, then click on frequencies, and under the frequency tab you have to choose a option called median. So you are going to get a median waiting time of in minutes for all the 3 specialist wards, and here you are going to get a what was the waiting time of all the 3 wards. Here first it is representing that what was the name of the variable. Name of the variable was label, and under that label we are having a 3 category: primary care, specialist, and the tertiary. And under the primary we got 29 patient, and under the specialist we got 38, and under the tertiary we got 13, and this will be taken as a capital N frequencies and the count, that how many patient visited under which department. And this is the waiting time of primary care 17, and specialist is 24, and tertiary is also 24. And here you can see that waiting time for specialist and tertiary was found similar, but there is a difference in the waiting time in the primary care. So might be two department will have the same what you used to call waiting time in minutes, but there is a difference in the primary care. So because of this reason we got here value 17. You are getting a significant results. For example, here also if you have got a digit around 23, 24, or 25, in that case you will be getting a p value more than 0.05, and you will find that test was found not significant. So we are getting here digit 17, that means 17, and there is at least one difference is there. So because of one difference we are getting a significant result. So descriptive statistics for waiting time by group using median you can add in the thesis or in research paper. So no need to add a whole table in the research paper or in the thesis. Directly you can write the results in the form of MLA style, as I told you in the previous test also. You can write the result shows significant difference of waiting time between. You can write the name of all the 3 units: primary care, specialist, and the tertiary center, and you can write that p value was found to be 0.003. So like this you can proceed, and even you can discuss the descriptive statistics in the form of what you used to call median time of primary was found to be this much, with the help of 25% uh, this what we used to call percentile, that is your interquartile range. So always write interquartile range with the median, and standard deviation with the mean. So this is the way by which mean you can carry out the Kruskal-Wallis test with the help of SPSS. And if any viewer is having any doubt regarding the Kruskal-Wallis test, I will be happy to answer in the further classes, or they can call me, they can send the email or WhatsApp regarding their queries. I will be happy to answer regarding Kruskal-Wallis or the Mann-Whitney U. And I'm going to upload both the video of Mann-Whitney U and the Kruskal-Wallis in my YouTube channel also, that is Amit Sharma. You can subscribe those channel, either ISF College of Pharmacy or my own personal channel, that is Dr. Amit Sharma. You can find in the YouTube for four further videos. So now we have a time, so I take another topics of today, that is error, because for that particular topic I have got so multiple calls as well as mails, that always you used to say that we are taking 95% of confidence interval and 5% chances of error. So what do you mean by that 5% chances of error, and what the error mean in the research? So I thought that before I proceed to other tests called linear regression, logistic regression, ANCOVA, MANCOVA, and general linear model, which are left for this series. I'll take error today. Let me see the presentation first. Yes.